right, good afternoon, everybody. This is Danny Mathematics once again. Today, we're going to solve the second example of how to figure out the area of a composite figure. Once again, this is the second example. I already have one example up on my page, so you can also check that example out. But this is the second example to how to figure out the area of a composite figure. Now, once again, the definition of a composite figure is just a figure made up of simple shapes, okay? So as you can see, you see that this particular composite figure is made up of a half circle or a semicircle, a rectangle, and a triangle, okay? So here's what I advise you to do. If you have color pencils or crayons or markers or even a highlighter, if I was you, I would highlight each particular shape is on color, okay? So I'm gonna do the semicircle or the half circle. I'm gonna highlight it pink. You can use any color, and I'm just gonna draw stripes so we can simply identify each part, okay? All right, the next part that I wanna identify is the rectangle. So I'm going to use green for the rectangle. So I'm just gonna put green stripes. All right, you can color them in, or you can just put the stripes just like me, just so you can just identify each part. That's the only reason why I'm doing this, okay? Just to identify. Okay, so my rectangle is green, the rectangular portion of this composite figure. And then of course the last portion is the triangle. So I'm going to highlight it sky blue, the right triangle, okay? So as we can clearly see, we have a semicircle or half circle, a rectangle, and a triangle. And for us to find out the total area, we have to find out the area of each particular portion first, okay? So in doing so, what we're going to do is, since we have three simple shapes that make up this composite figure, draw a chart and divide it into three sections. And within each chart, this is where we're gonna do our work to find out the area of each portion, okay? So the first part, of course, is a circle. Was actually a semicircle or a half circle. Semicircle, okay? It's a semicircle. The next part is a rectangle. And then the last portion of the composite figure is a right triangle, or you can just put triangle, okay? Now, next, what we're going to do is we're going to identify the formulas to find the area of each shape, okay? So, and also, ladies and gentlemen, if you don't have a formula chart or you just don't know the formulas by heart, all you have to do is just go on Google and just type in the formula of a circle, or the formula of the area formula of a circle, or the area formula of a rectangle, and then those formulas will appear, okay? So you can access those if you just search it through Google, okay? So the area formula of a circle is pi. Pi has a particular value. We're gonna go over that value, times r squared, or r to the second power, okay? All right, pi times r squared, okay? But in this particular case, as you notice, we don't have a whole circle. We have a half of a circle. This formula represents a whole circle. So if we only have half of a circle, right, that means that we divided the circle into two parts, right? So we have to divide by 2, okay? So this is the formula of a whole circle, but because we only have half of a circle, we have to divide this formula by 2, okay? So dividing by 2 becomes part of the formula because we are dealing with a semicircle or a half circle, okay? So I just wanted to talk about that. Now let's go to rectangle. The area formula of a rectangle is just simply the base or the horizontal side of the rectangle times the vertical side of the rectangle, which is labeled as the height. Okay, so it's just simply this base times height. Okay, and then a triangle, right? As you notice, guys, a triangle is half of a rectangle, right? So it's the same formula, base times height, but it's gonna be divided by 2 because a triangle is half of a rectangle. If you put the same triangle on top of this one, then it will turn into a rectangle, okay? So it's gonna be area equals base times height divided by 2 because a triangle is half of a rectangle or half of a square. Okay? So let's just go through each part. Let's just do the easier part first and then we'll come back to the circle, the semicircle part. All right? So let's look at the rectangle. All right? I'm going to label the base or the horizontal side as sky blue and the vertical side of the height as red so we can simply identify, okay? So as you can see, for the rectangle, the base is 6, okay? So 6 centimeters is the base. And as you can see, that the height of the rectangle is 4 centimeters, okay? So the height is 4. So simple. All we do is just plug in into the formula. Once again, remember it was base times height. All we're doing is just plugging in those values, the value that represents the base, which is 6, and the value that represents the height, which is 4. Simple, 6 times 4 is 24. So the area of the rectangle is 24 centimeters squared. Okay, but remember, this is only part of the total area. Okay, this is just the area of just the rectangular part. Okay, all right, now let's go to the triangle. Okay, all right, the base of the triangle. All right, the base of the triangle. Oh, okay. Now, they didn't really give us an actual value of the base of the triangle, so we're gonna have to figure it out. Okay, now let's look at it. From here to here, which is representing the two bases, the rectangular base and the triangular base together, the whole length is 10 centimeters, right? If we had the base of the rectangle and the base of the triangle together, the whole length is 10 centimeters. Well, we already figured out that the base of the rectangle is 6. So in order for us to find the base of the triangle, we're gonna have to subtract 6 from 10, okay? In order for us to get this particular part, okay? So once again, 10 minus 6 equals 4. So the base of the triangle is 4. Okay, once again, they gave us the length of both bases put together, and then we also figured out that the base of the rectangle is 6. So we had to subtract 6 from the total length of both bases to find out that the base of the triangle is 4. Okay, so that's how you do that. And then of course, as you can see, the triangle has the same height as the rectangle. So even over here, the triangle has a height of 4 centimeters. Okay? So once again, we're just gonna plug into our formula. Remember, it's base times height divided by 2, base times height divided by 2. So in this particular case, it will be the base of 4 times the height of 6. The height of 4, my bad. The base of 4 times the height of 4. 4 times 4 is 16. 16 divided by 2 is 8. All right, so the triangle itself has an area of 8 centimeters squared, okay? So far, we have the rectangle, we have the triangle, and actually I'm gonna write their areas inside, okay? So remember, we have the area of the rectangle, which is 24 centimeters squared. We have the area of the triangle, which is 8 centimeters squared. Now we need to find the area of the semicircle, okay? Now, let's go over circles real quick. We have a circle. Of course, we have a semicircle, which is a half circle, so we can easily just draw a line to slice it through, okay? So let's just act like we're only looking at the top part, okay? Which is this particular semicircle, okay? Just act like the bottom part is not there no more, right? Now, if there's a line segment that basically splits a whole circle in half, that line segment is called the diameter. The diameter. It's called the diameter, okay? That line segment is called the diameter, okay? Half of the diameter, which is the line segment that goes from the edge of the circle all the way to the middle of the circle, that is called the radius. That is called the radius, okay? Now, let's look at the semicircle's formula, okay? First of all, we do have a radius, okay? Radius squared, and once again, radius squared does not mean radius times 2. It means radius times radius, okay? So we do have a radius, right? But as you notice, we can't necessarily identify the radius as of yet from the semicircle because so far they've given us a diameter, right? Because from here to here is 4 centimeters, right? So we do have a diameter of 4, okay? But however, even though they haven't given us the radius, as long as they give us the diameter, we can figure out the radius, okay? Once again, the radius is half of the diameter. So if the radius is half of the diameter, then half of 4 is 2, okay? So we know that in this particular case, R, or the radius, will equal 2, okay? It will equal 2. Now, the last part that I want to go over when it comes to solving circles or semicircles is pi, okay? This little symbol right here, guys, represents pi, okay? Which is pi. And once again, if you ever forget the value of pi, just type in what is the value of pi in Google or pi, and then the value will pop up, okay? So the exact or the absolute value of pi is 3.14. 3.14, okay? But in most problems, especially on the middle school level, they just want the approximate, meaning the answer that is close to the exact answer, okay? And I know sometimes middle schoolers, they might have a little trouble with multiplying with decimals. So if you want to make it easy for yourself, you know that you might be a little off, but they just asking this for the approximate, then you can actually round 3.14 to this 3, okay? You can actually round 3.14 to this 3. So either you can use 3.14 if you want to be exact, or you just want the approximate value, then you can just round 3.14 as pi to this 3, okay? I'm just going to use 3 because sometimes with decimals it gets a little sloppy, okay? All right, so now all we have to do is just plug in into our formula. So once again, we have pi. So once again, I'm going to use 3 as pi times R, which is 2, right, to the second power, which means 2 times 2, 2 times in it, multiplying itself twice, okay? All right. Once again, we already know that the radius is 2, so I can erase that part. All right, let's do, of course, order operations, PEMDAS, right? Parentheses, and then exponents. 2 times 2, right, or 2 to the second power is 4, right? So we're going to have 3 times 4. All divided by 2, right? Now, of course, at the top, 3 times 4 is 12. So we're going to have 12 divided by 2. Then, of course, we have to divide by 2 because we only have a half circle. If we had a whole circle, then it would be 12. But since we only have a half circle, we have to divide by 2. Remember that. Okay? So the area of the circle will be 6 because 12 divided by 2 is 6 centimeters squared. Okay? So now, the last thing that we need to do, we have 6 right here. So the area of the semicircle is 6 centimeters squared. The area of the rectangle is 24 centimeters squared. And then the area of the triangle is 8 centimeters squared. Now the last and final thing for us to do to find out the total area is to add each partial area. Okay? Of course, 4 plus 8 is 12. 12 plus 6 is 18. Carry the 1. 1 plus 2 is 3. So this particular composite figure has a total area of 38 centimeters squared. And this is our final answer. Okay? So once again, ladies and gentlemen, make sure that whenever you're doing a composite figure, right, split the figure. Sometimes the figures will already be split, which this figure that I'm using, it was already split in the example, but sometimes you might have to split it yourself. But as you can split it into simple shapes, split it into the different simple shapes that you see, right, and then actually highlight or color in the simple shapes with its own color, okay? To kind of separate it so you can clearly see what you're doing. And then once you do that, create your chart, and then for each simple shape, find out the area of that particular portion, and then at the end, you will add all of the areas together to get the total area, okay? Once again, this is example 2. Example 1 is already uploaded, so make sure that you also look at example 1 for extra support and extra feedback. So thank you so much for the opportunity. Thank you.